Hello, everyone, and a warm welcome back to all the participants. So, participants, we know that we have to play the role of a DevOps engineer. And as part of a DevOps engineer is expected to come with a lot of skill sets in building the pipelines, connecting the various stages. So, participants, as a DevOps engineer, it's a very vital technology that has really changed the way the deployments are done. And especially in the current trends, the market is really moving towards container platform. The industry has completely changed into the container platform. So participants, today we will go ahead and spend time in understanding what is basically a container technology, what exactly is container is all about. In order to understand the subject of Kubernetes, you need to understand what is a Docker, what is a container is all about. So we'll start with the basics and we'll go and start doing hands-on into it. So participants, to set the expectations right, what I will do is I will go ahead and get started by giving you the basics of containers, Kubernetes, Dockers, everything one by one. So the best place to start with and start using the services, of the container services under AWS that involve ECR, ECS, Kubernetes. So we should know basically the definition of a container, why exactly a container is required, and what is basically a container and how they are useful for us. So I'm going to use the same code, participants, which we have been using in the last Terraform deployment. We will use the same code into our Kubernetes deployment as well. So before we hit anything else, let's understand what is exactly container and what is Kubernetes is all about. So to understand this, the best way is to visit the documentation of Kubernetes, participants. Kubernetes.io is the official documentation page. You hit this page, you don't need to do anything, or you don't need to do any kind of document. You don't need any other documentation about this documentation. I'll assure you. So how Kubernetes is branded? First thing, there is no company behind this. There is no profitable company behind this. It's an open source product. Just for your information, it's an open source product. So the term Kubernetes means, it's a German word, means the one who drives your ship, the helmsman. You might have seen the logo. The logo resembles some the one who drives the ship. So it's a German word, and they use a word called K8. K8 means the easiest way to notate Kubernetes. So what does this Kubernetes has to do here? This Kubernetes is basically a system that you will use for what automation? What kind of automation? Automation that involves deployment, scaling, and management of what kind of apps? Containerized apps. So the way Kubernetes is designed is, the idea of developing the container apps is one part, and next, after the development of the container apps, anything which involves deployment, scaling, and management of these container apps has to be done by a system. That system we will be using now is Kubernetes. But the question will come once again back to the basic, is that what is this container app is all about? Definitely, because you guys are not aware of what is container app. So participants, to go back or to understand what is container apps, let's understand the real life problem. Then I will relate with the container app. Now, what is a real life problem? Let's understand a real life problem. Participants, In our DevOps engineering pipeline that we have developed, can you tell me what are the various tools and services that you have been using to develop and deploy this code? Can anyone give me the insight about this DevOps project that we have done? What are the tools and services that we have used, participants?
Maven, Jenkins, GitHub.
Okay. So we have been using GitHub to put our code, to place our code. Maven we have used. We have used Java. We have used Jenkins for our continuous integration. We generated the artifact. We bundled the packer. We provisioned the Terraform. We bundled along with the Tomcat. So participants, generally speaking, let's go ahead and talk to a Java developer or a developer who's writing a Java code, something like this. No, we cannot expect a Java code, a Java developer, to go ahead and start using these all tools. Definitely, from my side, the answer is he may not be knowing all these tools because he know how to write a code. Now, the problem that I will face is if I borrow this code from the developer, what developer has to do? He has to write a code for me. Then from my side, what I have to do? I have to take this code, build it with Maven, bundle with install Tomcat, bundle along with Java packages, and create a jar project and start storing in S3. That means these many things I should know in order to get all the application up and running. That means finally, in order to get my app.var package, I have to go ahead and take the source code from the developer, build the artifact, and bundle it. Now tell me, participants, is this var package gonna just run? Is this var package gonna just run like this? Definitely no. What we should have? We should have Tomcat running. Now, taking the code, building the artifact is not enough. We have to also bundle with Tomcat. And we should make things up and running. Now, this artifact, if I go ahead and bundle, what I will go ahead and bundle, I'll go ahead and bundle in the form of a image. What is that image that we have built in AWS, participants? AMI. Did we not build AMIs? Participants using Packer? Did we not build using AMIs using Packer? Participants, everyone, are you with me? Hello? So participants, ultimately, it is the image that we have built that has bundled everything. Now, a simple and logical question I'll ask you. Can you use this image in any other cloud? Participants, can you use this image in any other cloud? AMI is only applicable for AWS. Can we use this AWS image in any other cloud like GCP or Azure?
Yes.
Come on, guys.
Yes, I guess.
Think for a minute. What does AMI stands for? What does the word AMI stands for? It's Amazon machine image. That means it's only applicable for Amazon. That means if I have to do this for Azure, what should I do? Once again, take the code, build it, test it, deploy it. With the help of Packer, I will need to build an image. Oh my God. Tomorrow, GCP. Take the code, build it, test it, provision it, Packerize it, create an image. Tomorrow, DigitalOcean. If these clouds starts coming into picture, you will only spend time in building images. Participants, am I clear now? For every cloud, you will start building images. Now, my question is,
Why is the need to like redo all this?
that's what is the answer. That's what's a question from my side. Why? Because a cloud image is very specific to that cloud provider. The image that you build is very specific to that cloud provider. So the question from the industry is, can we have such a product where we can build images that are applicable to run in any cloud provider? Can we build one such simple image that can get deployed across all the cloud providers? That's where the concept of containers came in. Or the concept of containers can help you. Container is what? You might have noticed containers, the ones that travel on ships, containers. You might have noticed this, guys. Containers, like they box your items, ship one place to another. This exact logic was followed in building Docker or Kubernetes images. So what people have done, or what the community has done, the community has adapted to an idea. The community has adapted to an idea that let's go ahead and build our images, which can bundle everything that we want to run our application. So starting with the operating system that you want. So you want an operating system, okay, put your operating. On top of that, some binary libraries. So you have some libraries that you want to run, maybe some kind of Java packages, something. Then you go ahead and get your artifact ready. Artifact is, in this current scenario, we are bringing our artifact as my app. Participants, what we need along with my app? Anyone? Participants, what we need to run my app?
Tomcat.
Very good. Tomcat. So take all these things, box it up like container them, put inside a container, put inside an image. And this image is now made available to you, me, everyone. I will build that image. You take that image from me. Instead of taking the source code now, you take the image from me. That's what is the next idea is. Instead of taking the code, building it with Maven, I will build the image where I will put the code, I will put Tomcat, everything that you need in one image and give it to you. Now, if this image is ready for you participants, if this image is ready, now basically the moment you start running, that becomes a container. And this technology was readily given by the company called Docker. Docker was the first company, I would say, to bring this idea into reality. Docker images are being built. Everyone are with me, people? Hello? So what Docker has done, Docker has helped the community building images that has everything that you need, you can bundle in the form of a Docker image. And the good thing is this image is now bundled with everything that you want to run your application, and the image is ready. You start going ahead and deploy wherever you want. If you want to deploy in AWS, deploy it. But the only thing is you should have support from container engine like a Docker. In Azure, you can go ahead and deploy the same image using Azure Container Image. You can go ahead and deploy into GCP, any other cloud you want. That means one single image is sufficient for you to run anywhere. That is the slogan or the logo. If you look at Docker, how Docker brands things. Docker says you build one single image wherever you want and run wherever you want. This is what is their Docker, or if you hit their hub.docker.com, run anywhere is their logo. Build and ship and run any application anywhere. That is the idea behind containers. So participants, if you are not able to understand, that's okay. Even if you're not able to relate with this, that's okay. So ultimately, what is the takeaway from this 10 minutes discussion is, instead of building cloud native images, we will build images that can get deployed anywhere we want. And we will build Docker images. Once you build Docker image, you run it, it becomes a container app. It becomes container. The moment you run a Docker image, it's called container. And in order to handle such hyperscale container environment, we need Kubernetes. Are we good participants? Are we good at this moment? Hello? Participants, are we good? Okay. Participants, do not worry. Let me demonstrate something in the form of a Docker image creation for you. I'm sure by this time, the moment I go ahead and build a Docker image, you'll understand it. So let's get started. So participants will use the same code that we have used previously. The same code I'm going to use now. You guys can see the same code I'm using. I have a copy of it on my local machine. The same code. Now I will add a very simple line saying that welcome to Dockers and Kubernetes. A very simple line. And I'm going to go ahead and add it to my machine. Git, can you add these changes? Git, can you go ahead and do a commit for these changes? New line entry for Dockers and K, it's Kubernetes. Git, push these changes -u origin upwards, branches, develop branch. I am using a develop branch, so changes will go ahead and hit the develop branch. So participants, double check whether the changes are available now for the part of the develop branch. Now the changes are visible. Everyone, are we good with regards to the version control? The changes, are we good? Can I have a quick round of confirmation from everyone? Participants, are we good with regards to the source code?
Yes, come.
Now, what I'm going to do is I'm going to go to my AWS console and I ask, hey, I want to use Dockers to build my images. So let me go to my master DevOps instance and ask, hey, master DevOps instance, do you have Docker running? Because I want to go ahead and build Docker images. So let's get started, participants. And do not worry, participants, every single topic that I'm discussing here, I will document here. So do not worry about the documentation. Right after the session, I'll be giving you the documentation. So Docker installation, we will attempt now. Okay, cool. Now I'm inside my EC2 machine, my EC2 instance. I'm inside my EC2 instance. Step one, I'll go ahead and make sure the machine is up to date. Participants, everything I'll do in front of you right from scratch. So what I've done, I have done the source code changes in front of you. The changes are cool, good. Now, what I want to do is I want to go ahead and start using Docker now. So I will ask Docker, are you running on this machine? Clearly, no, Docker is running on this machine. So let's go ahead and install Docker apt-get install docker.io -y. This command will go ahead and install Docker on this machine. That's simple. It is participants to install Docker. Sudo apt-get install docker.io -y. This one simple line is sufficient for you to run Docker. Yes, Docker is up and running. Let me just check some temporary files. There is space and any space left. Let's remove all these temporary files. Why? Because to keep some space. Now, clearly, Docker is running on this machine. Participants, you have seen, yes, previously there was no Docker running. Now Docker is running because I've just installed the Docker. So participants, no one is expected to know all the commands. So hit Docker as a command. It will tell you the list of all the commands. All the commands that I'll give you a list of all these commands. Do not worry. So it's time for us to go ahead and focus on what we want to do. I want to go ahead and build a Docker image. So Docker build is a word that you should look for. Docker attach build. It says build an image from a Docker file. Yes, we have to go ahead and build an image from a Docker file. So what I'll do, I'll go ahead and continue asking Docker, hey Docker, can you go ahead and build me an image? For this, I need your help. So Docker will tell me, okay, in order to build a Docker image, you are required to pass a Docker image file, a file called Docker file, without which it will not be able to build it. So what I'll do, participants, I'll go back to my source and I add a new file called Docker file. The name of the file, we will keep it as Docker file. Participants, remember, whenever you're writing a Docker file, always keep the letter capital D. You don't need to put any extension. Just the name of the file is Docker. That's all. Participants, everyone, are we good? Participants, everyone, are we good? Okay, so how to get started with writing a Docker file? Participants, Docker file is an instruction manual where we will go ahead and tell what you want to do inside Docker or the image that you want. So to start with, participants, you have to have a clear picture of what you want to do with Docker. Can anyone tell me, participants, what is that your image should have? Your Docker image should have. Anything that you are sure about your Docker image? What you want to have inside your image, participants? Anyone? What are your expectations from the Docker image? What are you expecting from the Docker image?
Containerized image.
Very good. So participants, what I'm expecting from my Docker images, I want to have my Tomcat. I want to have my, application. I want to have everything that I have bundled. I will. So what I'll go ahead and ask is, hey, Docker Hub. That means Docker Hub is a repository where you'll find plenty of Docker images across every platform or every service that you're looking for. Mostly you'll find it. So I'll go ahead and ask, hey, do you have Tomcat, by the way? I'm just going to ask, do you have any Tomcat? So participants, it is able to list a Tomcat. And the amazing thing is, participants, even Tomcat is available as a Docker image. That's really wow. So how to use this? Scroll down, they will tell you how to use this Docker image. Yeah. So this is the base in which come on guys, come on. Participants, check your audio. Okay, so participants, how to use it? Any latest version, if you just go ahead and put, they'll tell you use a keyword from where you want to use it, from the Docker image, from Tomcat. So participants, I'll start writing the Docker file saying that, hey, I'm interested to use the base image called Tomcat. If you don't mention anything, it will pull the latest one. From Docker Hub, I would like to go ahead and build latest image of Tomcat. That's cool. Now from this Tomcat people, tell me, what are your expectations? What is that more you should have in your image? What more you want to have inside your image? Anyone? What is that you want to have inside your Tomcat image? Participants, what are your expectations from the Tomcat?
we need to run that source code Java.
Very good. Instead of saying the source code, can I say the artifact? The artifact,
Yes, exactly.
right? I want my artifact. That is, I want to go ahead and take my artifact. The artifact will be normally under the target folder under myapp.var package generally. Into where? Into our Tomcat Tomcat folder. What is a Tomcat folder? Web apps folder. Base or the home. So I'm picking this and say, hey, I would like to copy. Inside that, hope you guys remember there is something called web apps folder. My app.war. I want to copy this. So participants, the command for the copy is copy. Copy. That's it. I want to copy from the current folder whenever there is a build happen. My application, my app.war package should get moved into my app.war package. Isn't that cool, participants? 2 lines from Tomcat, from Docker Hub, I'll build a Tomcat. Copy my target file, my app into my app.war. Am I clear, everyone? Participants, am I clear? Now, this is what is your Docker file. That's it. So, in my Docker image, I want to have Tomcat bundling along with my application app my app.war package. And one thing that I want to be sure is I want to expose my port 8080. Why? Why? Because Tomcat runs its application at port 80. So we should tell which port of your container should be opened. We'll open port 8080 of our container. Participants, can I have a quick round of confirmation from all of you? If you have understood the logic that I've used here. I have used Tomcat because my application, my app.war package, you guys have seen, it will run inside the Tomcat. So I'm running inside the Tomcat, exposing port 80. This is what is my Docker file, people. So what I'll do, Git, can you add all these changes? Git, can you go ahead and commit the changes? Docker file added. Git push these changes -u origin, which is developed. So the latest changes have been pushed into Docker. So now what I'll do, I'll go to my system and confirm whether the Docker file is added. Under my repo where there is a Docker file is added. Cool, Docker file is added. Now it's time for me to go ahead and ask, hey, EC2 instance, can you get me the copy of that Git folder? Git, can you get the latest copy of this source code? There is a repo, which is ETA beta. Right now, it says nothing because current branch, Git branch -a, we are running on the master branch, but we have a develop branch where the code is sitting. So we will say Git, can you switch switch branch to develop. Now the branch is shifted to develop branch and do an ls, you will find the Docker file. There you go, guys. The Docker file is ready. So what are you waiting for? Nothing. So Docker build me a Docker image. So it will ask me, where is your Docker file? In the current folder it is. And then I'll put a keyword called -t. T means tag, tag with some name. This is my app image that I want to build. Hit enter. Participants, with this, Docker takes my instruction, downloads Tomcat, and it says failed to register layers because there is no space left on the device. No space for the device. What should we do now? So running out of space. This is a challenge that needs to be addressed. So what I'll do, participants, this is something which I didn't expect. The EC2 instance will run out of storage. So I'll go to my EC2 instance and ask what is the current storage. It's 8 gigabytes. It's I feel the storage is not sufficient. We have to increase the storage. Let's go ahead and hit storage PM. For now, what I have to do, participants, I have to drop this one and ask, hey, I would like to go ahead and increase the size from 8 gigs to 100 gigs. At least I should have done this. From 8, I'm increasing up to 100 gigs. And to modify, don't do this in real time. You have to stop your machine and modify it. Modify. So I'm increasing the volume from 8 gigabytes of volume to some 100 gigabytes of volume. And we will be getting charged because storage is getting increased. So definitely pricing will get applied. So you can see here, modification is ongoing. Now it is a little off track, people. We are on the other side where we are increasing the volume of this machine. I felt that 8 gigabytes of volume should be sufficient, but it's not sufficient for this instance. We are bound to increase it. So now, participants, I hope you have realized, even in cloud, these challenges will still remain. Storage. A lot of people I get to see, they'll ask, if things are running in cloud, we should not be worried about storage. See the real life scenario. Yet, storage is a concern. So what I'll give you a clarity about what is this. This is the machine where I was using all the services like we have been using for every uh, resource that we want. So this was the DevOps master instance. So into that instance, I was trying to run. I think volume is attached. So now you can see 8 have become 100. So let me double check and confirm you participants if this is running. I think it's in the state of optimizing the volume. So let it be. So now let's continue to use this machine now. So at least I have increased the volume. There is something that you will notice after this now. So this machine is ready with 100 gigabytes of volume. Let's go ahead and do a connect to this instance. And continue. Now we'll continue building an image, but you'll notice another challenge yet be resolved. You'll notice now. So let's consider the root privileges, hit the machine, clear the screen, and you will still see the repo running. We'll shift to beta repo. There should be a Docker file. Yes, the Docker file is still now. So Docker, please build me an image by putting up a tag for my app. The location for your Docker image or the Docker file that you're looking is in the current folder. The dot resembles that. So it's downloading. One more time, Tomcat bundle from the internet. Participants, you can still see it says no space left. But participants, have you seen? Did I increase the volume? Did I increase the volume? Yes or no?
Yes.
But still it says no space left. Why is that? The answer is this one, LSBLK. LSBLK will list the blocks of volume. There is a volume which is 100 gigs, but at this moment only 7.9 GB of partitioning is done. So 100 gigabytes partition is not extended towards 100 gigabytes. You can still see it's only 7.5, 7.9. So let me go ahead and double check. Now after this, no spaces left. So this could be possibly the mount part is not extended. Okay. Then there is one more step that I have to conclude. Modifying volume on AWS EC2 instance. I have modified that volume and let's confirm we have modified the volume. Done. Yes. If size does not reflect your newly expanded volume, you must extend the file system of your device so that you can use the new space. That means we have to extend our file system, which we haven't done it. So let's extend it. So we have been extending. The answer is no, we didn't extend it. And let's confirm file system extension, how to extend the file. I'll use the Zen one, sudo lsbk. Yes, we have 8 gigs. We have extended to 16 gigs. And now EC2 for name def1. Okay. This file system. Okay. LSPLK. Sudo resize file system / dev2 xvda1. xvda. Device or resource busy while trying to open xvda file not system. What he has asked us to extend, for example, extend the file system, use the following. Give me a couple of minutes, guys. Let me just be sure about the file system. xvda. Nothing to be done. I'm extending this xvda. Let's follow one more time the steps. Connect to that instance, check the LSBLK. Sudo grow part xvda to 1. Okay, thereafter, ask me to go ahead and extend the file system. xvda sudo lblk zen and mount system. Grows the data size. This of real-time section. And SPLK. Cool. I think it did extend, guys. Let me double check. Docker, can you start running an image for me? I'll tell you what I've done. Okay, now it's working. File doesn't exist. Okay, that is something I will fix. Participants, now this is very important learning in terms of the storage. Now I'll explain you how did I handle this in that. So participants, initially I had an EC2 instance and the storage that was associated was only 8 gigs of storage. When I was trying to run Docker, it failed to create Docker and images. Then what I've done, then I've modified to become an additional storage I've mounted, which is 100 gigabytes storage. Everyone, are we clear? This was a new volume that I've added. Are we good? Participants, are we good? From 8, I have modified up to 100. The problem was the file system which was there was only limited to 8. It asked me, please extend the file system to support this extra 100 gigabytes of volume. That means the file system. Like in Windows, you get to see drive C, in which you will see all your folders and files and system. Same way in Linux, the file system which is available needs to extend to use this block of storage, 100 gigabytes of storage. That's where the command XFS, that means the file system was expected to extend its file system to support this 100 gigabytes of storage. For that, I went into AWS documentation and checked it. So he said, whatever the device that you had, just go ahead and run the commands that are mentioned here. The first command, if you look at the first command is all about mount point. That means where is your mount point? So this was the mount point. So we have looked the various blocks of storages we had. So we looked at various blocks of storage. After that, what did I do? As per the instruction, I did go ahead and grow part of 8 to 100 gigabytes of volume. So I have extended it. After the volume extended, I have extended the file system. Grow FS. That means grow the file system. This is the grow part. Grow part means it will go ahead and identify how much of volume change is now from 8 to 100. That is a change that is learned. Next, we are able to go ahead and attach the file system on this mount point. So slash was the mount point. So with that, I was able to go ahead and increase the file system. And I am able to now use, instead of 8 gigs, totally 100 gigabytes of volume. Now the new extended volume for this EC2 instance is 8 to 100 gigabytes of volume. And just for your information, participants, this has nothing to do with Kubernetes learning. This is my current problem. This has been my current problem. But good thing is that you have learned in case in a scenario where you will run out of storage, you will follow this method by increasing the volume and extending the file system. Everyone, are we good at this moment? Are we good with the problem that I had? The problem that I had was no storage. I have extended storage and now storage is up and running. That means extra storage has been accommodated. Now, after this, came back to Docker, started to build a Docker image and asked Docker, you go ahead and build me an image. Docker said, yes, I will build an image for you. But it failed at step number 3 to copy the target file. That's what is the clear context. Hey, copying is failed. Why? Because the file that you are looking for is not found in the location. Is that the scenario? Let's navigate to target folder and do an ls. Participants, do you see myapp.war package available here in the target folder? Do we see any target folder available here? Participants, do you see any target file inside this target folder? Do you see anything like myapp.war package? Participants, do you see anything called myapp.war package? None. There are no packages now. So what I will do in order to accommodate it, I will go ahead and say Maven clean and package it. Because of Maven clean and package, now it will go ahead and build me the packages, or you will get the output. This is the first time we are building our Maven package on this machine, so it is expected to take some time. So don't worry, it is downloading all the Maven packages. Okay, now participants, finally, file is created. So participants, now it's time for me to go ahead and confirm by navigating into target folder and do an ls. You see, it's an application file, myapp.war file. Before it was not available, I built it, it is now available. Now, one more time, we'll ask Docker, please help me to build this image. Finally, guys, it did build an image. The challenges that I had to address were the storage and file not found. Because of this, it has taken time. Now, file is ready. The image is ready. So participants, the moment I go ahead and run Docker images, the command is Docker space images. It will list the images that you have. A Tomcat image and a my app. Everyone, are we good at this moment, people? Are we good participants? Now you can see there have been two images, and the image that we are looking for is a Docker image. Can I have a quick round of confirmation from all of you people? Hello? Participants, are we good at this moment?
Yes, Kumar.
So participants, let me quickly revise what I have been doing till now. Participants, where it all started from? The same source code we had. We had the same source code from our previous project involving the Terraform. I use the same source code. Now to the same source code, the extra thing that I've added is the Docker file. Into this Docker file, I have been clearly instructing my machine to use Tomcat and take the artifact, build them together and expose port 80. So it has to go and build me a Docker image. The context of the Docker image was have Tomcat as the underlying package, bundle the application into it and expose port 80. That was the idea behind the Docker image. We bundle the Docker image. So Docker image is built now. So where did I build the Docker image? I did build my Docker image on my EC2 instance. So what were the challenges? First thing, Docker was not available. How did I go and install Docker? Simple command. Sudo apt-get install docker.io -y is the command that I used to install Docker. So Docker was installed. After this, what did I do? I did run another simple command. Docker build me -t with a name called my app with the current folder. Current folder means in the current folder, the Docker file is available and I built an image. And that's what is the image, people. Now, this image is something which will go and deploy wherever you want. You want me to deploy in a Kubernetes cluster? I can deploy. You want me to deploy into a GCP Kubernetes cluster? We can deploy. We can deploy into Azure Kubernetes cluster, wherever you want. But this has to have a central storage. So storage with regards to container storage, regarding the container deployments. I think people, we cannot get it done in the next few minutes. So participants, as expected, let's do one thing. As expected, it did not go because much of the time has taken by the volume creation. So participants, what is my plan is, I'll take this discussion latest further for tomorrow. In the next part of the session, what I'm going to do for you people is, I'm going to go ahead and explain you the concepts of Kubernetes one more time. I'm going to explain you the concepts of Kubernetes, and I'm going to go ahead and make the cluster ready, where we'll deploy this image into Kubernetes cluster. This, I wanted to spend time for today, but the challenge that I had to spend more time was on the volume creation.